Okay, so now these are what now sequences. So as per your requirement, you can create your sequence object and later apply on your table. Okay, and below write down to view all sequence objects. To view all sequence objects in Oracle database, then we use a data dictionary. Then we use a data dictionary. Data dictionary, okay, is user underscore sequences. So user underscore sequences. And now we can see, okay, suppose you want to see how many sequence objects you created. Okay, so here I will come back here. My sequence name, I can see it now. And now I can write select from user underscore sequences. So here, how many sequences we created here? 3. And these sequences, even though we can drop, so drop sequence SQ1. Drop sequence name. So like you can drop your sequence, and when you come back and see, your sequence is dropping. But the sequence is dropped, but this sequence we applied on S1 table. So your data will not drop. Your data will not drop. Your data will be having in the database table. But what happened on this column? Sequence facility was dropped. Okay, your data will not disturb. Okay, just we sequence facility, whatever we applied on this column, that facility I was dropped. Okay, right on. Okay, right. So these are the sequences in your oracle. Okay, how to create and apply on your table. And the next topic takes heading partition table. Partition tables. Okay. So now tell me guys here, what is the mean by partition? Partition means uh, a small part, a portion. Okay, no? Uh, so generally, partitions, why should we want to create on a tables? Okay, for example, suppose you have some use and very big tables are there now. Some use or very big table is there here. So in this table, suppose I didn't apply any partition. That means this table is not doing any partitions. So just a normal table I created. And in this normal table, I'm storing so many rows. So many rows. Okay. Like we can save here so many rows. Like assume like this, there are 1 lakh rows was there in this table. Okay, now? Suppose on this table, if I need to apply, okay, some restriction, sorry, some request I'm going to sending to this table to retrieve particular or specific rows data or row data I want it. Then what we want to do, whenever user is needs some data, some particular data he need, for that purpose he was sending some query request. And based on query request, your Oracle server, whatever user sending the request to server, the server will go to your table and searching from top to bottom. From top to bottom, it was search. So that means 1 lakh rows means 1 lakh rows only searching. For your required data purpose, your server is searching entire table. So that means my entire table we need to search. So whenever it will be searching like this, automatically time consuming. First thing, it was first what now? Time consuming problem. That means it was time taken process to each and every required data purpose. Server will go to your table and your entire table should be searched, find and send back to client application. This is time consuming process. Later, the performance, okay, whenever you need to searching from top to bottom entire table, if the table is having a 1 lakh rows, that means 1 lakh rows we need to search. That means what happened? Your performance also degraded. Your performance also degraded. Okay, it will not give good performance. It's a bad performance. Will give it to retrieval your required data from this entire table. Okay, now so time consuming, performance wise degraded, and whatever the data user wanted, the data user how he will get a delay. That means very slowly he was getting his required data because of reason searching time is more. That's why when searching time is more, then your output also will get a slow. Yes or no? So that kind of problems are we are facing when your table data or your tables are not a partition. So that means when we are working on a very large scale data tables, at the time what happened, when we want to retrieve some data, for the data purpose your server will searching on entire the table. So it will lead time consuming process, and retrieving data is very very slow. Okay, and performance wise also low performance will give it us. Okay, now because of reason searching entire the table. So instead of doing like this, what the people will do, they will be created some partitions. They created some partitions. So partition P1, partition P2, partition P3. When I design my table into small units, small portions, if I divided here, and in that small units, if I stored my data, then what is the advantage here? Means now we can see. So when user is required some particular data, then table test, and he will be calling what now? Partition P1 if he call it. So he was very clearly mentioning here, and we are sending our request to server. You can go and search so and so partition, and from there data can be sent back to me. So it's very clearly we are sending that which partition the server want to search. The partition name clearly we mention. Whenever we mention this request, so this request will go to what now? Server. Then server, what it will do, it will be directly going to which partition? P1, and P1 only searching and retrieving your data, but P2 not search, P3 not search. That means your time is saved now. Yes or no? Because before partition what happened? Entire table. After partition what happened? Required partition, required area only searching. The remaining area was not searching here. For so many examples are there in real time. Okay, nowadays you can see supermarkets. If you go to Reliance, yes or no, DMart, If you go to supermarkets, how they was arranged their products? Their products are there now. How they arranged products? In the partitions wise. Okay. For example, if you go to some biscuits and chocolates, this kind of the items will be having in one rack. Suppose you needed some cosmetics like soaps, okay, vagaira vagaira, that was having in one rack, and some other items in another rack, other items in another rack. So when they divided into your products, they will divide it into separate racks. Understand now? So whenever they keep like this, what is the advantage of customer? Customer have any advantage if you keep like this? Yes. So customer, suppose he wanted, he need to purchase some soaps. Then what it was happened, if you go to ask a salesperson, I wanted soaps. Salesperson clearly telling us, madam or sir, so and so third rack is there. You can go to third rack, and there it was available. So there are 10 racks are there. There are 10 racks are there. But instead of 10 racks searching, directly I'm going to where now? Third rack. Because there my available, that means my required products are there in the third rack. And that was given, that information given by who? Salesperson. So then customer, what he will do, he was not searching rack number 1, not searching rack number 2. He was directly going to rack number 3. And required products, he will be picked from that rack. And remaining racks also, he was not searching. So that means, your time saving now. Whose time is saved? Customer time is saved. Performance is good. Okay, na? And quickly, I can take my required product. Okay, na? So suppose if you're not doing partition, all products are in the clumsy way. Okay. Partitions, then what happened? That one rack you have to, there cosmetics are there, oils are there, everything is combined in one rack. What it was happen? So much a time it will take to get your required product. Okay, now like that. That's why nowadays you can see in shopping malls also, if you go to South India shopping malls, Chennai shopping malls, there also each floor wise they're divided into partitions. Can you find out now? For example, ladies floor is first floor, gents second floor, kids third floor. So they divided. Okay, so saris are available in one, normal dresses are there in the second floor, and menswear third floor, kids wear fourth floor. They divided, and they will be given first floor so and so, second floor so and so, third floor so and so. They was kept into the lift area. Yes or no? Then customer can easily understand that when they see, okay, suppose I need a menswear I required. So I'm going to checking menswear, third floor. Then immediately I will go to third floor. I don't want to search ground floor, first floor, second floor, third floor. Not necessary. If you search like this, what happened? Lot of time consuming process. That's one thing. Next, nowadays you can see librarian. It's called a libraries. Libraries also, different kind of books are there, right? But every different types of book, they're divided into partitions. Suppose some comic books you wanted. Comic books are keeping into one particular rack. And some historical books you wanted. The historical books are keeping into one more rack. Okay. So some novels are there. So that will be keeping into one more rack. Some horror stories books are there. So that will keeping into one more rack. So when they divided the books into racks, then what is the advantage of user? We are going to library, and there one librarian sitting there, and we are asking him, sir, I wanted comic books. Then what librarian will say? Take left or take right and left. There is a rack number 2 in that it was available. Then this user directly, as per their direction, it will go and going to where now? Second rack, and the comic books are taken out. Okay, now. So when you divide your items in the partitions wise, the first advantage is what now? Time saving. And quickly retrieve, quickly take your required product. And performance is a high performance will give it us. So how we can say these examples? in real world, same as in the database. For example, I said when you're working in companies, so in working in companies means you're interacting so much big tables, and the tables are having lakhs of records. So in the lakhs of records, if you're not doing partitions now, then what it was happen, for each and every required data purpose, you need to search a entire table. And that is not only one time. How many times are you sending your request to server? Server will go to your table that many times and searching that many times. It's a lot of a time consuming process. So in that cases, they will create what now? Partitions. On where? On tables. And once created partitions, then your required data you can take from or based on your required partitions wise. Okay, now? And like this, here in Oracle, how many types of partitions we can create on my table means there are 3 types of partitions. One is called as a range partition. Second one is called as a list partition. Third one is called as a hash partition. So in our Oracle, it was supported 3 types of partitions on table. One is range, list, and hash. Okay. Now let me see one by one. What is range partition? Here observe. Range partition. So in the name only there, partitions can be divided or partitions can be created based on what? Based on what? Range value. So particular range wise, I need to divide my table into partitions. Okay, now for example, 0 to 500 is a one range. On that, I can create one partition. 501 to 1000. This is another range. I'm creating one more partition. So like particular range value basis, you can divide your table into smaller units, small pieces. Okay, now? And that is what we called as a range partition. Okay, now? So what we say, created a partition table based on a particular range value. A particular range value. Okay. Now syntax observed. How to create this? So create as usual your table, create it, and how many columns you required, the column names you can mention, and suitable data type of column, and if it is required size, and so on. Okay, so up to your table definition and table we can create, but without breaking here, then continuation you can do now. What I'm going to do, I'm giving here partition by range. And this partition by range, are you created this partition by ranges based on which column data wise? That's called a key column name. That means which column data wise your partitions are divided. Okay, now? So the column name, that is called a key name. After that, how many partitions you need to divide? Okay, the partitions I'm giving. So partition, and I want to send partition name 1, sending values which is less than of value. Okay, like in the next partition, so partition name 2, which is values which is less than of a value. Okay, comma, and so on. Okay, so like this, you can design your number of partitions. Okay. Now we can see the examples we will discuss now. Observe. I'm creating one table. The test number 31. Okay. So your table, you can take employee ID number, employee name. So whatever your required columns you can mention, and salary. Okay, number of some size. If I leave like this, if I break this, what it was happen? A normal table is created, but on the table there is no partitions. Okay, so that's what I want to do. There is no need to break here and continuation. Now you can add your tag. What is the tag here? Partition by range. And partition by range, I am creating, I'm dividing my partitions based on which column? Salary column. The salary column wise, I'm dividing my partitions. Okay. Then how many partitions you want it now? Then you can write partition P1. I'm sending values which is less than of 500. So which is less than of 500 means, it means what now? 0 to 499. This value, this range values will come and save under P1 partition. So in P1 partition, from which value to which value will save? 0 to 499, because less than 500. Yes or no? So that is what. Next one is called as your partition P2, sending values which is less than of 1000 I was given. That means 500 to 999. This range values are saved under which partition? Partition P2. The next one is what now? Partition P3, sending values which less than of 2000 I was given. That means 1000 to 1999 will be saved under partition P3. So like I was designing my partitions, I'm creating my partitions based on some particular ranges. Then okay, fine, your table successfully created. After created, now data I need to store. I need to store my data. Then I'm storing. Insert into test number 31, sending values, ID number, the name was Smith, and now I'm giving here 250. Now when I inserted this data into this table, this data where it will be saved? Partition P1, yes, it will be saved under P1. Now I'm going to give it here, the second one, Jones, and here 1500. Where it will be say 1500? Partition P3. Next, if I was given here 3, and now I'm taking here Adams, and I will take here 1200. Then partition P3. Now I'm giving here, for example, 4. Okay, the name was Ward, and I'm taking here 850. Where it will? Partition P2. So I just saved like this and finally committed to permanently save my data. It's over. And now we can come back and see your table test 31. So this is the data arrangement. This is the data arrangement. So 250 will go to save under first partition. 850 will come under to save into second partition. 1512 will come under third partitions. Okay, now? So after your data is nothing but your products, your books are arranged in the partitions wise. Then what next? Users. Now user will call his required data from this table. Okay. Suppose that user wanted a partition P2 data. Then how to write? Select a star from test number 31 and partition of P2 if I'm calling. Then partition P2 means as per this request will go to Oracle server. Server will go to directly your P2 partition. In the P2 partition, whatever the data was there, immediately the data will be picked and sending to your client application. So that means here, what it was happened, it is not searching this row, not searching this row, not searching this row. Okay, directly will go to second partition. The second partition data immediately send back to client tab. But remaining rows, remaining data will never search. Okay, now in the same to same, suppose if I'm asking P3, then P3 data only retrieval, and it is not searching P1 and P2. Suppose if I want to go for P1, then what happened? Directly P1 will take it out. Got it my point? So these are the way the partitions how to create it on my table. But here one thing observe, somebody's have a doubt. Here my last partition range, how much? Less than 2000. Suppose you are asking, sir, if I want to send my data, suppose I'm going to sending here 5, some name is Miller, and now I'm saying 2500 I'm sending. Okay, now tell me this data where it will be saved. P1 na, P2 na, P3 na. Okay, what is your last range value? 2000. This is 2000 or 2000 above na. When you try to insert like this, it was showing error. It was showing error. What is error? Inserted partition key does not map to any partition. So that means this is partition key value. This key value is not matching with the P1 because P1 range is what? Less than 500. So here it is not matching. This is not matching with the P2 also because P2, what is here? Less than 1000. Next, this key value is not matching with the P3 because P3 less than 2000. So that means what you understand here, whatever the ranges are you given here, if the more than that range value, more than that range values, if you try to insert, the data will not allowed and data will never inserted. So as per your partitions wise, how much ranges are you given? So it will be checking your data 2500, first checking with the P1, not matching, P2, not matching, P3, not matching. So finally what it was say? It doesn't mapping. Mapping means connectivity. It doesn't connect with any partition. So that is a very clear message. What it was saying that inserted partition key value. This is partition key because my partition key, I was partition by range. What is the key column? Salary. So key column, that is key column. So that key value, partition key value 2500 does not map. Map means connectivity. Does not connecting to any partition. Does not connecting to any partition. So that's why the data will never allowed. Okay, now? So this is one range partition, how to create and how to retrieval. Right down below. So after syntax, take example.